Okay, so welcome back from the coffee break, and we now have the last round of talks, at least for today. And the next on schedule is Will Schroeder. He's a researcher and red teamer from various groups' Adaptive Threat Division, and also co-founder of the VIR framework and contributor to Powersploit, and I think also author of the tool PowerView. Yeah, and he will talk about offensive Active Directory exploitation with PowerShell features, and of course with this tool PowerView. Thank you.
Cool. Can you hear me? Hello? Hello? Cool. All right, so I have the PowerView Offensive Active Directory at PowerShell. This is my first Troopers conference. It's been awesome so far. It's already one of my favorite conferences, and I hope to come back next year as an attendee or a speaker potentially. One second. All right, why can I not? I can't actually change slides. That's not right. Okay, there we go. Cool. So again, I'm a co-founder of the tool PowerShell Empire, the Veil framework, and also PowerView and PowerUp. I'm a core Powersploit developer, and again, a researcher at various groups' Adaptive Threat Division. Of all the tools that I've written, PowerView is definitely one of my favorites. I use it on every single engagement. So just a show of hands, how many people use either Empire, Veil, or Power Tools or Powersploit on a regular basis? Like, cool, that's awesome. So if you guys have any in-depth geeky questions, just hit me up after. I love talking about this stuff. So real quick to start, what I'm not covering, I'm not going to go over any kind of memory corruption attacks, not because I don't think they're cool. It's just we don't tend to use them on engagements. I'm not going to go over too much Active Directory background. There's, people have written entire books or entire libraries of books talking about Active Directory. So I'm going to give a few small pieces and then really focus on kind of the cool stuff that you can do with PowerView. I'm also not going to cover Mimikatz or Kerberos attacks in depth. This is mainly because they've been covered better and in more depth by others. A really, really good presenter and researcher is Sean Metcalf Pyrotech, who I'm going to cite repeatedly in this presentation. His blog is adsecurity.org. He talks about a lot of that stuff in really good depth. I'm also not going to talk about PowerShell weaponization, which is kind of an entirely different problem. What I mean by that is how can you actually run these commands on the host and get the results back in a secure manner. We like to use Cobalt Strike or Empire on engagements, but if you want to talk about that, grab me after. What I am going to cover, just a little bit about Active Directory from an offensive perspective. Why do you need to care about this? What can it do for you? And what's PowerView and what's this PowerShell thing? The next section is going to be identifying interesting users and figuring out where they're located on the domain, which is something we do very, very frequently. I'm going to go over local administrator enumeration, which is one of my favorite features in PowerView, but how you can determine the members of a local group on a remote machine without administrative privileges, and you can do some really cool stuff with that. I'm going to go over GPO, Group Policy Object, Enumeration, and Abuse, some really kind of cool stuff you can figure out with just talking to a domain controller, some stuff on Active Directory ACLs with permissions, a whole bunch of stuff on Active Directory Domain Trust, which is another one of my favorite topics, and all throughout the presentation, I'm going to have a lot of kind of tips and tricks and a lot of one-liners. So hopefully you get a good use out of this presentation. I'm going to tweet out the deck right after I get out. So I want it to also function as a really good reference for people. I have a lot of ground to cover, so I'm going to move pretty quick. I have 70 slides, so we'll see how it goes. So first, Offensive Active Directory 101 and why PowerShell. I love this quote from ObscureSec, one of the Powersploit authors. He says, "Blue is the new black," referring to the PowerShell window. So at its core, Active Directory is a way to organize users and computer objects in a domain. So it's used to authenticate users to machines, to different types of resources, and have a really nice centralized location to triage all this access. It also has really nice stuff like security policy, centralized management, different things we're going to touch on during the presentation. Red teams and real bad guys have been using and abusing Active Directory for years, but there hasn't been a huge amount of Active Directory information from an offensive perspective until recently. So real quick, why not use the built-in Active Directory commandlets? That's a question I've gotten from a lot of people. So the RSAT-AD PowerShell module is a set of built-in Microsoft Active Directory commandlets, but it's only installed on servers that have the Active Directory domain services role, so basically domain controllers. It's only compatible with PowerShell 3.0 and up, and you have to install something on the machine. We really like to live off the land with existing tools, so we wanted something that was PowerShell 2.0 compliant in case we hit Win 7, fully self-contained with no dependencies, and usable without any installation. So that's what PowerView is. It's a pure PowerShell domain and network situation awareness tool, 2.0 compliant. It was in a couple different repos that bounced around. It's now officially part of PowerSploit. The bleeding edge version is always going to be in the development branch of PowerSploit, which is going to stay a couple months ahead of master. And there's no installation, no external dependencies. You can load the entire script into memory and do all this type of enumeration without touching disk. So a quick side note, some of these LDAP optimizations. So a lot of the PowerView functionality under the hood reduces down to kind of linked and chained LDAP queries. There's some optimizations in the back end. For example, if you query something across a trust, it reflects everything through the primary domain controller for your current domain. So this is nice. It kind of gets around some network segmentation. And a lot of this stuff in PowerView isn't revolutionary, but chaining a lot of this functionality lets you do some really, really cool stuff in domains. And also a quick note on the pipeline. If you guys haven't used PowerShell before, the PowerShell pipeline, as opposed to the Linux pipeline, pipes full, complete objects instead of just text. So this lets you perform really complex chaining and filtering, and you can do these really kind of crazy, awesome one-liners. A really quick example would be with PowerView is give me every user who's logged in the last 7 days and sort all those users by their display name. So it's this is going to touch. I'm going to touch on this several times throughout the presentation with the pipeline. So the first section, identifying and hunting your prey. Who are my administrators or users I'm interested in, and where are they located? So before you start kind of going about your lateral spread, you need to figure out who you're actually going after. There's a couple PowerView commandlets or functions that really help with this. So if you want to get users that match a particular pattern, you can use wildcards and get users with a particular name. You can get groups that have particular wildcard names in them, like GitNet Group Admin, which we use all the time. And you can get all the members of a group. Also, on all these functions, there's a -filter attribute, so you can do your own kind of customized LDAP filters. So if anyone's ever done AD query, any other kind of stuff, if you have any of those strings or particular things you want to search for, you can add those into PowerView really easily. A few tips. If you want to get all the groups a user is effectively a part of, so recursing up. So even say you have these kind of crazy nested groups and you want to say everything he's a part of, you can do GitNet group with the username. If you want to get all the effective members of a group, so if there's nested groups and you're kind of at the top and you want to recurse down, you can do the -recurse option with this GitNet group member. If you want to search the global forest catalog, which is a distributed repository that contains a searchable partial representation of every object in the entire forest, you can just specify GC for global catalog whenever you're doing any of these functions, and it'll search the entire forest. Another thing we sometimes see are privileged machine accounts. So machine accounts can sometimes end up in privileged groups, which Sean Metcalf on AD Security, that link, has a really cool post about this and the implications of it. What this means is if you can compromise a particular machine, you can occasionally take that machine account as opposed to a user account and use it to compromise large components of the domain. So with PowerView, if you want to find any computer accounts in any privileged group, GitNet group admin count. The admin count is a particular field in Active Directory that if that group or user was ever a part of a certain set of protective administrative groups, directly or transitively, they have this small little field set. So it's a really easy way to get all the privileged groups in the entire domain. We can pipe that with the pipeline and full objects to say, give me every single member and recurse all the way down. So give me the entire set. And then check, are any of the members like a machine account name? So nice little one-liner with just 2 functions, and we can figure out this really useful thing on a pen test. So separated roles. A lot of organizations, I'm sure people that go on pen tests and red teams here are very familiar with this. A lot of organizations separate out administrative functionality in how they set up the user and group roles for Active Directory. So a lot of users might have an unprivileged account and a privileged account. So if you're desktop admin or domain admin, they're probably not going to be running around with that privileged access all the time. So if we correlate some Active Directory data on some of these objects, you can pull out groupings of accounts that are likely owned by the same person. So a really simple example of like John or John-admin. But on pen tests and red teams, we really like to hunt for an administrator's unprivileged workstation, compromise that, and then compromise their privileged credentials. So separated roles, kind of a simple example. If you want to find all user accounts with a specific email address on a domain, and you can do this kind of across trust or kind of a trust mesh which I'll go over a little bit later in the presentation. But you can just use that filter and just say, OK, mail equals John or whatever the domain name is. And if they have that same email registered for multiple accounts, you can pull out all the linkages. So pretty simple, right? Like, not too crazy. Doesn't seem that awesome. This is a much more complex example. So I'm going to explain step by step in the next slide exactly what this is doing. But this is essentially finding groupings of similar display names in Active Directory objects. So one of the things with the kind of correlating these groupings is these vary by environment. So you kind of have to do a little bit of raw data enumeration and figure out what's the particular field that you might be able to correlate and link for a particular enterprise. So sometimes it's the display name, sometimes it's the mail, sometimes they have a custom attribute that you can pull out. Or it might be, location. We've seen stuff where they have, their desk number, written in or something like that. So it's kind of customized per environment, but is usually not too hard to find. So this particular example, this is what the output will look like. Get net group member, and you can see, OK, this Dave McGuire admin, Justin Warner admin. And you can see, OK, this is the pattern they're using for administrative accounts, which is this .a. So what this is actually doing behind the scene is, in plain English, is getting all the members of domain admins in the particular domain and returns the full, complete data objects for it. That's what that full data is specifying. Then for each object that it gets, it's going to pull out the first name and last name from the display name field in the returned Active Directory objects. And then it's going to query for users with the same first name, last name. So you see here, it's pulling out these first two tokens, splitting that and re-querying with a wildcard to try to figure out, OK, this is the pattern, who are these people that can kind of be grouped. So, get all the members, and then for each one split, tokenize it, take the first two components, and then redo another query with it and select out just the display name and the SAM account name. So I really like kind of doing the data mining kind of component in Active Directory engagements. It's really interesting. Oh, and one note that I forgot to say with this is most of this functionality, including this, you don't need any kind of elevated privileges in the domain. There's a huge amount of information that you can get with just basic user privileges, or even a machine account, if you happen to have that without an actual authenticated user. So OK, now that you've identified who you want to go after, you have all the members of a nested desktop admins group or something like that. The next thing you want to do is figure out where those people are logged in. So kind of map it to different machines in the enterprise, and you can start to build these type of trust relationship maps and figure out, OK, I need to go from this machine to this machine, get this user, and then hop here. We generally break this phase down into pre-elevated access and post-elevated access. So pre-elevated is when you have regular domain, unprivileged account tokens or access. This is usually in the lateral spread phase when you're trying to kind of early on in engagement, figure out how you're going to elevate in the domain. Post-elevated access is usually when you have something like domain administrator credentials. This turns into the demonstrate impact phase. So, let me figure out where the CEO is and key log them, or I don't know, in the US, we're allowed to go read people's emails. I hear it's not quite the same in different places that actually have privacy laws. But I don't know. It's, when you actually want to demonstrate, demonstrate the impact for a particular red team, you get a lot more, sorry, I'm also super jet lagged, so I apologize if I kind of trail off. But when you're doing the post-elevated access phase, you have a lot more tools in your arsenal about how you're going to go about getting this location data. As in, you can just ask the domain controller for all the authentication events and then figure out exactly where people are. Pre-elevated, it's a little trickier, but there's still a lot of options for you. So Invoke User Hunter, if people have used PowerView, this is usually the function they tend to use. It's a really flexible function that will query Active Directory for all hosts or take like a target list. There's a lot of options. Query Active Directory for users or target group or any of that kind of stuff, a single user or show all users. And it uses some Windows API calls under the hood, which is network station, user enum, and net session enum. And it runs these calls against all the machines in the target list. So you can get a huge amount of information about who's logged in where without having administrator privileges. I have no idea why Microsoft allowed the APIs to return all this information from an unprivileged account, what they do. So this is really useful to figure out who's logged in where. We really like using the -showall flag. So by default, it'll only say, like, show me where domain admins are logged in. The showall gives you all the raw data. We'll save that out to a file and then grep through that as we're targeting different groups and users during an engagement. This is kind of an example of just what it looks like. You're going to query all the computers for domain controller, get the logged on, the network station, user num, getting it logged on, and getting it sessions for everything. One thing to note, with this default behavior with Invoke User Hunter, you're touching every single machine. So depending on the environment, this can be really, really noisy. So if your client has any kind of internal network controls or filtering or anomaly detection, if you just kick this out with default options, you might actually find they might kind of catch you or detect behavior. A better option is what we call stealth user hunting. So it uses an old red teaming trick where it queries Active Directory for all the users and extracts anything it finds in the home directory path, the script path, the profile path, or distributed file shares and domain controllers. So the idea here is to figure out what are servers that have a large number of users connected up to them. From there, we do this getNet session, which is a wrapper for net session enum. We run this against each file server, and it gives us this remote session information about who's logged in where, and then we can match that up against our target list. You get pretty reasonable coverage, usually about anywhere from 50 to 85% as much of the data, but it's a lot less traffic. It's also significantly faster. But like the previous example, it doesn't need administrator privileges, and you can also use that -show-all flag to get all the raw data back that you're grepping. Just kind of example what it looks like. Query all this information, get me all the home directories, and then just run one API call against each file server. So if you have 20 file servers that show up in script paths, it's super, super fast. It will take maybe just a couple of minutes to get all this data back. So local admin enumeration. This is something that we've been doing for about 2 years. I haven't seen a huge amount of information about it in most other locations. I think there's only one other tool I've heard of, local.exe, which I think was an old NT resource kit binary, but we use this all the time. So in Active Directory, there's something called the WinNT service provider, which is a remnant leftover from Windows NT domain deployments. They left it in because of backwards compatibility, which always ends up being Microsoft's Achilles heel. This is just kind of a really terrible, gross example of what it looks like calling this stuff raw. So a lot of this is what kind of PowerView will look like underneath. But if you run this call against a particular server, IP, or whatever, this will tell you all of the members of the administrator's group on a remote machine, and you don't need administrator privileges to pull this information back. So I really don't know why they allowed any user on the domain to pull this info, but you can do some really cool chaining stuff, especially when you hook it back up with the user location data. So I'll go over the kind of a crazy example here in a little bit. So getNet local group is the commandlet wrapper that has a ton of options that wraps that AD WinNT service provider type stuff. So if you do getNet local group server, it'll just return by default all the members of the local administrators on a remote machine. If you want to figure out what are the local groups themselves, the names, you can do -list groups. And if you want to specify something different, like another common one we'll use is remote desktop users in a remote system to see who can log in. You can specify that with the group name. If you specify the recurse flag, it'll resolve any of the member results that are groups themselves and find all the kind of nested stuff all the way down. So if you do getNet local group recurse on the server, it'll give you an effective set of all the domain users that have local administrative rights on that remote system. Also with User Hunter, kind of combining these two things together, if we do Invoke User Hunter target server, it'll find the target set of users that have admin access to that particular target server and just go hunt for those to see where they're logged in the domain. So if you're going after like a SQL box or SQL server or something like that, you can run this and get that location data back about who has those credentials and where they logged in. This is kind of what it'll look like, all from an unprivileged domain user to a remote system. You can see the computer name, the account name, the SID, description, disabled, last login, password last set, all that kind of stuff. One thing this can be useful for is, if anyone's ever heard of the KB2871997 patch, the pass the hash patch. So if you find the built-in domain or the built-in local administrator account, which has the RID of 500 on a system, if it's enabled, then you can pass the hash with it. In this case, it's disabled, so we can't pass the hash with the local account, but a lot of environments still have that component enabled. So you can gather all this information before you're just kind of like spraying PSExec or WMI or something around everywhere. So we really like gathering information and then doing targeted strikes on maybe just a handful of systems and then getting whatever the objective is. So derivative local admin, this is probably one of the more trickier topics in the entire deck. But large enterprise networks often utilize heavily delegated groups like I mentioned. From an attacker's perspective, anyone who could be used to chain local administrative access can be considered a target. And I'll explain more in the next slide. One of my colleagues, SixDub, has a really nice write-up on this. It's really in-depth. It's a lot more information than I have here. So as an example, say we're going after Tim, a domain admin, who's on a machine that has the workstation admins A in the local administrators group. You know, this could be a help desk or something like that. Workstation admins A contains a user Bob. Bob's machine can be administered by workstation admins B. Workstation admins B contains A and kind of all the way down. So if we exploit this user Eve all the way at the end of the chain, we can use her access to compromise the machine where Bob is, grab his access, and use that to compromise Tim's machine. So Eve is effectively a domain administrator because of the machines that she has access to and the user location of who else is logged in on these boxes. So Eve's administrative privileges derive through Bob. This picture kind of makes it a little nicer. So if you have this domain admin logged in here, Bob is a member of this workstation admins A. We're essentially compromising here, dumping credentials, compromising here, and hopping, and doing these kind of really crazy chains in the field. We've done chains up to like 7 hops deep on engagements. It can take some time to correlate all the location admin information, but we do this on most red teams whenever we're in the field. So the process of how you can actually pull this off, it requires several hops or several kind of different components. So you want to run Invoke User Hunter, stealth show all. So this will give me all the user location data that I can find in the entire domain with only touching a few kind of file servers and domain controllers. You can do a getnet local group recurse on your target machine. So in this case, it would be on this box right here. And you're going to identify all the effective users who could administer the target you're after. You look at all those results, you match it up with the user location data, and you say, oh, okay, this guy's logged in here and he has access to here. Then you do a getnet local group against that guy, and then just kind of work your way backwards. And then just kind of continue until you actually have your path of exploitation. A side note, I'm not going to go into a large amount of detail on this, but we're hackers. We like automating things. We don't like doing stuff by hand. So one of my other colleagues, Waldo, Andy Robbins, started automating much of this process. So he takes a lot of the gathered input from PowerView and then adds a little graph theory and Dijkstra's algorithm in with it to automate the chaining of this local admin access. So if you just dump all this location to admin information into kind of a graph backend database, this is a solved problem. Like graph theory has been solved for decades, so he can just kind of walk through the entire thing. If you're interested in that, talk to me after or check out his blog post on it. I think it's the only post on the site right now. It's really, really cool stuff. It's still kind of in its infancy. So GPO abuse. This is kind of some brand new shiny stuff in PowerView. I was modifying some of the code last night at the hotel. Hopefully I didn't break anything. But why not just ask the domain controller for all this kind of group policy user login information? What do I mean by that? So I'll back up a quick second. I'll start with some GPP stuff and then get more into the GPO user location components. So who here has heard of GPP or has used it on a pen test? Hopefully, yeah. It's one of the classics, right, in the last couple of years. So many organizations have historically used group policy preferences to set the local administrator password for machines. Now, this is really, really bad because Microsoft decided to publish the AES key they use to encrypt it. So even though it's encrypted, they published it, and it's the same key for every single machine. So if you have an enterprise that has group policy preferences enabled, you can pull the local admin password in plain text just by decrypting it. Powersploit has a get GPP password function, which will automatically go to a domain controller, search for any of these files, and then decrypt everything and just give you the output. So I know it's kind of really tiny print, but here's the password, here's when those change, but importantly, it'll tell you the path of this file. So this path is part of a group policy object that's applied to machines. So one of the things we used to run into is, we would get, when we started, we would get these GPP passwords, and we tried to figure out where can we actually use these credentials, like where can we log in. A lot of times I've heard of people, we just load it up and just scan with the credentials across everything in the network to see if they would work. But there's definitely a better way. So if you noticed in the group policy object, there's this GUID here that represents the GPO that's applied that has this, this password attribute set. So if you find any of these and you have any hits, with PowerView, with a nice little one-liner, you can just do getnet OU, so give me all the organizational units with the, and you do this -GUID flag, and what this will do is there's an attribute called GP-link in organizational units and sites in Active Directory, so that'll say, give me all the OUs that has this particular group policy applied. So under this GPP GUID, we would just take one of these, right? Just plug it right in. And then for each result, give me all the computers that reside in this OU. So in this one-liner, you can say, okay, I have a GPP GUID, and you can get every single machine where that local administrator password is set in about 20 seconds while only communicating to the domain controller without having to try authentication events to every machine in the domain. So we saw this, we built that a few months ago, and then we started diving more into some of this GPO enumeration. So group policy objects can also determine who can log in the local administrators group or the remote desktop users group. So it can determine the membership of these local groups when the policy is applied. So with GPOs, they set it with the restricted groups attribute. With group policy preferences, they can actually do something similar with the groups.xml, which is actually kind of tied into a bit here. But besides just setting the local admin password, you can determine who's actually a local admin on that box. So if we have a user account that we're interested in, so say we have Bob and we want to figure out where does he have admin access in the entire domain, we can just ask the domain controller, correlate a couple of objects, take some of the results, smush it all together, and then we can figure out this is where Bob has admin access. So the PowerView function that will do this is called find GPO location. The process is it takes a username or a group, resolves that to a domain SID, then it does a getnet group -username to recurse up, and it says, give me every single group this person is a part of. So then you get a big list of, say, like a dozen SIDs or something like that they're effectively a part of. Then it runs a function called getnet GPO group, which will pull all group policy objects and check if any of them have the restricted groups attribute set. You match up that target SID list to all the results from the getnet GPO, and then this will give you all the GPOs that set your particular target on any machine, or that add your target to the local administrators on any machine where the GPO is applied. Then we can take those GPOs, and through the GP link attribute, we can enumerate all the OUs and sites. Then from there, we can query all the computers that are part of that given OU. So a multi-step process, but you don't have to worry about how this works. You can just run this, so find GPO location, username json.a. It does everything in the backend, and it gives you a nice little list of these are all the computers in the entire domain. This is a small little demo domain I have, but you just run this, and it'll just dump it all out and tell you here's where your existing user or target user has access. There's also an inverse. It's like find GPO computer admin, which give it a computer name, and it'll tell you every domain user that has a GPO linked access into particular groups, all while only talking to the domain controller. So no packet is actually sent to any of these target computers. Cool. The next section is going to be Active Directory ACL. So some people know this, not as many people know it as they should, but Active Directory objects have permissions just like files do. These permissions can sometimes be misconfigured, or they can also be backdoored for persistence. And what's awesome is that what's awesome from an attacker perspective is most organizations do not look, audit, or alert on any of the permissions on their Active Directory objects. They might have something, crazy file integrity monitoring on domain controller, but they don't actually check who has, editable rights to the domain admins group. Part of the reason why is there hasn't been a really easy way to do this. There's probably a product out there which will kind of enumerate some of this stuff, but it's still kind of a new area with not as much attention being paid to it up to this point. So the PowerView function to enumerate this is get object ACL, and this little dash resolve GUIDs thing will actually resolve all the strings of GUID rights to actually what the right means. And you just pass it a SAM account name, a display name, or whatever else. And it'll give you all the ACLs that are applicable to that particular domain object. There's also a set ACL object that lets you modify these for backdooring reasons, which I'll do more on that in just a little bit. This is kind of what it'll look like. In this example, I'm getting all the ACLs for the JSON user, and I'm just applying like a helper filter saying, give me everybody that can reset this user's password. So we see, okay, this identity reference is this test lab Justin user has the rights to reset the password on JSON frame. So we're talking about ACLs and we talked about GPOs. The access control on GPOs is of particular interest. This is because any user that can modify a GPO can trigger code execution on any machine where that GPO is applied. There's about a dozen different ways you could do this. You know, startup task. You can change like kind of proxy settings and have it point to like a man-in-the-middle server. We really like doing just pushing out an immediate schedule task with the PowerShell one-liner to all machines where the GPO is applied. So if you want to do this, just getNet GPO, pipe it to getNet object ACL. So pretty simple, and it'll say these are all the rights for these users for that particular GPO. Like for example, testlab Will, me, has edit rights on this particular GPO, and then we can use some of the previous one-liners we talked about to actually figure out these are all the machines where that GPO is applied. So Will effectively has admin access, or effective admin access at system level to every machine where this GPO is applied. All without him showing up in any kind of privileged group. He can just be in domain users and nothing else. Auditing Active Directory ACLs, pulling all this stuff will give you an enormous amount of data. You know, we're talking about hundreds and hundreds of megs for some environments of just plain text. So there's a helper function called Invoke ACL Scanner, which will search all the access control list in Active Directory for every AD object. And it finds ACLs that have modify rights, so it doesn't worry about read or kind of the basic unprived rights. And where the user's domain RID is over 1,000. So non-built-in users that have edit rights to some kind of Active Directory object. So you can take all this and just pipe it out to a CSV or something like that. This helps narrow down the search scope a bit. It's still really pretty difficult, and at this point we haven't automated the analysis of this yet. So it's a lot of go through the raw data and kind of figure out what the misconfigurations or potential backdoors might be. So next section, has anyone ever heard of admin SD holder? A couple of people. So admin SD holder is a special Active Directory object that's located at CN equals admin SD holder, and then whatever the rest of the domain, or admin SD holder system, and then whatever the actual rest of the domain path is. So admin SD holder is essentially like an access template. And it's used to prevent the accidental modification of privileged accounts. So there's a particular set of privileged accounts, so like domain admins, schema admins, enterprise admins, whatever else, that if their permissions change, so if you say, I want to add Will to have password reset rights to domain admins, admin SD holder will be automatically, the permissions associated with admin SD holder will be re-pushed out to everything that it's protecting by a special process called SD prop. So every 60 minutes, SD prop says, what are the permissions of admin SD holder? I'm going to take that and clone it to all these protected users. So it keeps you from backdooring domain admins or something like that. There's a bit more information here. But what's cool is if we just change the permissions in admin SD holder, then we have a permission backdoor that's pushed out to every single protected user in the entire enterprise. So if we add an object ACL to admin SD holder, and we want to say, give me all rights or give me password reset rights, now this unprivileged JSON user can modify any member of domain admins, can reset passwords for anybody in domain admins, can modify anybody, remove people, do whatever they want to domain admins, even though they don't show up in any privileged group. So I think this is pretty cool. I'm sure there's actors that have done this in the field, and people just haven't thought to check for it yet. Targeted plain text downgrades is the next ACL component. So it's another legacy backwards compatibility issue. But in Active Directory, there's a field that says store password using reversible encryption. What this means is instead of just getting a hash, if you do something like DC sync, you can get the plain text password for a user. It's not set in many accounts, but we can modify it for the purposes of a kind of a backdoor. So if we do set AD object in PowerView, and you have to do some like XOR and all this kind of stuff. But if you run this one-liner, it'll set that particular field for the account. Taking it one step further, in PowerView, if you do invoke downgrade account, whatever the username is, it'll downgrade the encryption, it'll set the reversible encryption flag, and then forces the user to change their password on next login. So if you run this, then you can go back and DC sync, and you can actually get the clear text password for that particular user in a really targeted manner by just modifying the ACLs on 1 or 2 people. So it's kind of useful to where, if you have a SQL admin or something like that, or if admins are using a jump box through RDP that you want access to, then you might be able to get it this way. And speaking of DC sync, there's a small set of permissions needed to execute DC sync on a domain. You don't have to be a domain admin. You just need a certain set of permissions to actually execute the DC sync replication functionality. So it's just these 3 rights. I think the last one might not actually be needed, but it's at least the first 2. But these particular rights for replicating directory changes allow domain controllers to replicate information between each other. Now, in this example, I added Jason Frank to this with these 3 particular rights. So Jason Frank, in this unprivileged user, has access to DC sync any password in the domain, even though, again, they don't show up in any kind of privileged group. So PowerView lets you really easily enumerate any users or objects that have these DC sync replication rights. And it's kind of a little bit of a nasty one-liner, but yeah, that's why the slides are kind of there for reference. What's even better is you can modify these permissions super easily with a couple of flags. So with this one line, and you do a target distinguish name, so the DN of whatever domain you're going after, whatever user want to have the backdoor, -rights DC sync, and this adds a DC sync backdoor for that particular user in the domain that probably won't be found. Like for example here, so even though Jason does not have admin rights to the DC at all, it can't dir admin $C$, he's just a part of domain users, no kind of privileged access. He can DC sync the KRB TGT hash whenever he wants. So this is a really nice little kind of subtle-ish backdoor. It's definitely a lot better than creating a domain admin user or something like that admins tend to look for. This is pretty cool. I've gotten to use this in the field one time. In a client, it's still there. They don't know it's there, and they have no idea how we keep coming back and creating golden tickets as much as we want. So it's a lot of fun. The last section is domain trust, or why you shouldn't trust Active Directory. So Active Directory trust, I used to think they were kind of black magic. When I first started red teaming, my boss was telling me about trust, and he'd run in all tests and just hop the trust and do all this, and I had no idea what was going on because I don't come from a system administrator background. But all trusts do is they link up the authentication systems of 2 domains, and they let these domains exchange authentication traffic. So it essentially lets you take users in domain A and grant them rights to resources in domain B and vice versa. These trusts form these interconnected relationships. A lot of times it happens during acquisitions or subsidiaries or things like that. But all a trust does is it allows for the possibility of privileged access between domains, but it doesn't guarantee it, except for one caveat, which I'll go over here in a few slides. So why does this matter? Like, why do you really care about trust from an offensive perspective? So red teams have been abusing trust for a long time, but previously there weren't a lot of tools that really automated a lot of these components. So it would be a lot of in-all test, AD query, and doing a lot of this stuff by hand that used to take weeks or maybe months to actually map out the entire mesh and relationships. But red teams, a really good example would be if you have a high security environment and a lower security kind of a domain, subsidiary domain that's linked up with the trust. If you're a red team, maybe you keep persistence in the lower security domain and then just hop the trust whenever you actually want to have access to the priv component. I really, really like trust. I've written several blog posts about it. The links are there. That's probably one of my favorite topics in hacking is offensive Active Directory domain trust. So That's what one of the first functions in PowerView after its user hunting components was starting to build functionality that lets you really easily operate across trust and enumerate the components of trust. So some of the examples would say, getNet forest, trust forest domain, give me all this forest contextual information, the domains within it, and all that kind of stuff. The one we use a whole lot is getNet domain trust, which is an equivalent of NLTest, essentially, purely in PowerShell. There are native Active Directory services kind of versions of these, and also if you do a -LDAP flag, it'll do just kind of pure LDAP querying that will be reflected all the way through your primary domain controller. So you enumerate these trusts, you do all this, and if a trust exists, at a minimum, you can query all information from the trusted or trusting domain. So if a two-way trust exists, say you want to get all the users or all the groups or all the group members or anything like that across the trust, all you have to do is just do a -domain flag, whatever the domain name is. So most of the functions in PowerView, all the enumeration functions, accept this -domain flag, and then you don't have to worry about any of the complexity of restructuring your LDAP queries and doing all that. So, okay, there's some stuff you can kind of figure out the forest and maybe the trust for your particular domain. One of the things we realized was we have some clients that have dozens to hundreds of domains spread across several countries, geographic regions. These can get really, really crazy. I wish I could show you an image of kind of one of the trust meshes. It's insane. But we soon built a function, Invoke Map Domain Trust, that will say, give me all the trust in my current domain, and for each result, go get all the trust for those domains, and kind of recursively crawl this entire trust mesh. Again, you can do that LDAP flag if there's kind of network segmentation. If it's a flat network, just by default, this will try to touch the primary domain controller for any of the foreign trusted domains. So invoke map domain trust, pipe it out to CSV. You see, okay, here are the source domains, target domains. Is it a parent-child trust, an external trust, crosslink, all that kind of stuff. And, it'll give you the direction, one-way, two-way, inbound, outbound, that kind of stuff. So, okay, this is kind of cool and kind of be useful. We did this, and we were kind of mapping stuff out by hand. But this data is still, it's very, very raw. And when 6dub, again, came on board to work with us, one of the first, he looked at me kind of crawling through all these CSVs and was like, this is terrible. Why are you doing this? This is, come on. Do a little analytics, throw something on it. I don't know why I didn't think of it. But he built a tool called Domain Trust Explorer, which will ingest the output of map domain trust. It'll take the CSV, and then it can do kind of nodal analytics on it. So shortest path, centrality, things like that. My favorite feature is it can output GraphML. That's digestible by, we use YED because it's free, but anything that handles GraphML for a mapping application, you can use that to build visualizations. And there's a bit more information there. But you can turn kind of this raw data that might have hundreds of columns or hundreds of rows into a really nice, pretty picture for outbriefs and management and all that kind of stuff. We've actually had clients start to request this as a deliverable because they didn't have any other kind of way to enumerate all this. And very frequently, we understand an organization's trust mesh, what we call it, better than they do. So you can see these colors actually mean different types. So red is parent-child, green is external, blue is crosslink. And you can see, okay, say I pop out here in court, my target is crown jewels. You can say, okay, I need to hop from here to here, and you can kind of start mapping your way down to figure out how can I hop through this trust mesh and actually get to the objective. Getting all this data and building the graph takes less than an hour for one person. So it's pretty cool, pretty useful, another function that we run on nearly every engagement. So malicious SID histories is the next fun component. So this article was pointed out to me. It was published or it was pointed out to me recently, but it was published over 10 years ago. So SID histories are an Active Directory protected attribute that are used to support migrations of users between domains. So when you set a SID history for a user, it essentially says, okay, this user has all the rights that they had from the previous domain. It's supposed to be from one domain to another. But people knew for over 10 years that if you set the SID history for your user to be something like enterprise admins, then you effectively have those rights. So this attack has been known, but it was largely theoretical for over a decade. Until Benjamin Delpy, Gentle Kiwi, and Sean Metcalf, again, got together last year and worked out that with golden tickets, you can set the SID history attribute in a golden ticket and then really easily hop up a trust. You just do the -SIDS or /SIDS argument for Mimikatz. So if you compromise a domain controller in a child domain, you can create a golden ticket that has the SID history set to be enterprise admins, and you can compromise the entire forest. So this kind of blew my mind the first time I really learned about it. It doesn't work for external domain trust because of SID filtering, but it does work for domains within a forest. So this means that if you compromise any domain administrator in any child domain in an entire forest, you can compromise the entire forest. Because the forest itself is the trust boundary. The domain is not the trust boundary. But most clients design their networks assuming that domains are the trust boundary. So they would have like a dev domain or some kind of semi-partially quarantined domain somewhere in the network, saying like, okay, we're not going to worry about that. We'll protect whatever the forest root is. But every single domain administrator credential within 2 minutes can be used to compromise the entire forest. Even if there's network segmentation, I've done this in the field. It's pretty cool, pretty awesome. Pop a foreign subsidiary and then use it to compromise the mothership across the ocean in 5 minutes. And advice from Gentle Kiwi. This is a common theme from ObscureSec and Skip Duckwall and Sean Metcalf, these guys that work in the Kerberos space. Like, if your forest is compromised, there's a million ways to backdoor this stuff to keep persistence. Like, it's the only solution, honestly, is to rebuild from bare metal. So, like, for example, I know people know about resetting the KRB TGT account, right, to roll stuff for golden tickets. Because of this, the Trustpocalypse, you would have to roll the KRB TGT account for every single domain controller or every single domain in the forest, because any user in those with golden tickets essentially can become enterprise admin. So it's not just sufficient to roll one, you have to roll every single one in the entire forest. So again, really, really bad, just rebuild from bare metal, which, yeah, it's not cheap and it's not hard in any way whatsoever. But so that's most of the content. I have a couple minutes left. A side note, on my GitHub, I've actually released cheat sheets for PowerView, Empire, and PowerUp. So there are 2-page PDFs, high-quality PDFs that you can print out. We give these out at the trainings we do at Black Hat and things like that. So kind of what it'll look like, there's a whole bunch of other kind of stuff, but it tries to break down all these different functions and flags in a digestible way that you can use on engagements. I wrote these because I even had I wrote the tool, and sometimes I have issues remembering all the functions and flags and parameters and all that kind of stuff in it. A few credits and thank yous. Thank you to Sean Metcalf, Pyrotech, for guidance, ideas, and awesome information on Active Directory. His blog is phenomenal. If you do anything with Active Directory from an offensive or defensive perspective, you need to just start reading his posts. He's got dozens and dozens and dozens of them. It's some of the best information in the space that I've seen. Thank you to Benjamin Delpy and Vincent. I do not know how to pronounce his last name because I'm a stupid American, but for Mimikatz and his DC sync capability. Thank you to Ben Campbell Meatballs for PowerView modifications and some of the LDAP optimizations. And thank you to Justin Warner and the rest of the Adaptive Threat Division for helping me build PowerView, give me ideas, and helping just make the tool much, much better than it started out. So that's it for, I have, maybe a minute or two for questions, something like that? Of course. So, and again, these slides will be up. I'll tweet out with the Troopers hashtag here right after I get out.
Yeah. Well, thank you, Will. Great.
Thanks. And so that's my Twitter, blog. I'm also on Freenode and the Armistice channel and the PS Empire channel. So any questions at all? I know there's a ton of information really, really fast, but yes?
One moment, please. The mic, please.
Oh.
Is there any way of turning SID history off?
Not that I know of. Again, I'm not a sysadmin, but it's an established existing attribute. Like, you don't have to do a schema expansion or anything like that. So it's there. I know there's ways to potentially maybe detect a certain event log events or something like that used for them, but there's
I'm doing it with golden ticket. Even if I check the SID history in the database, it's irrelevant.
Yeah, that's the difference between the theoretical attack people had talked about 10 years ago and the golden ticket component now is previously it involved having to modify something on a domain controller, which could have been detected. But with this, it's super easy, and you don't need to actually edit the ntds.dit on a DC. Any other questions? Cool. Cool. Well, if you want to talk to me after, come grab me. I'll be out in the hallways. And thank you guys so much. I really appreciate you coming to listen to me. So,
Again, thank you very much, Will.